It is 7 o'clock. Hello, everybody. Welcome. Hi. So, introductions. My name is Jonathan Leitschuh, and I am the developer, one of the two primary developers who wrote grep. And I also wrote the testing suite that runs for WPILib every time anybody contributes to it and makes sure that all of the code works on the Roborio.
Hey, my name's Sam Karlberg. I'm mostly a developer on grep. I've been working on WPILib for the past 5 years or so. So I've been pretty deep in this for a while. Yeah, so I do a lot of work on the tools, so grep, Smart Dashboard, Robot Builder, Outline Viewer, all that stuff. If you've used it, I've written it.
And I'm Kevin O'Connor. I'm the FRC robotics engineer with First Headquarters. So the control system is sort of my primary job responsibility, interfacing with our partners at WPI, National Instruments, Cross the Road Electronics, making sure we've got good system integration, a common direction, and things like that.
All right, so to kick us off, I'm going to ask you guys, why are you here? What do you expect to be getting out of this presentation? Anybody?
Yep. So I've been working with these tools for a while and want to know what's involved and what's the best way to work with you, and if we find bugs that we can fix, or if we come up with extensions, how to integrate with what you guys are.
All right.
Always looking to fully utilize the WPI library and see what's coming in the future, how best I can utilize that.
So how best you can use that on, like, in a robot program first. Okay. Anybody else? Nope. All right. So if this will go to the next slide. There we go. All right. So just a quick agenda for today. We're just going to do a quick overview of WPI Lab. So what's involved with the libraries, all the components to it, stuff like that. We're going to talk about what's new this year. So what we added during the off season that you can now use this year that you couldn't in 2016. We're going to talk about how you can build all the components for WPILib. That includes just individual components like Smart Dashboard versus integrating your own custom code into WPILib. So if you want to, add a custom sensor, for example, stuff like that. And also for creating custom vendor libraries. So what CTRE is doing this year for their canned talent stuff. We're also going to talk about what's our components in WPILib, what we have. So how we've organized WPILib, so how we've broken down the dependency tree, what components depend on what other components all the way up. We're also going to talk about how we actually work with Git, with our version control, with GitHub, which, again, that's new this year. Before we were on a semi-private version control server. All right, next slide. Okay, so the WPILib mission. I don't want to get this wrong, so I'm just going to read this verbatim. So our goal is to enable first teams to focus on writing game-specific software rather than focusing on hardware details. So we're abstracting away all the hardware stuff that you need to know, so how to interact with speed controllers like Victors or Cantalons or Jaguars, stuff like that. You don't have to worry about writing all of that code because we already supply it for you. So you can focus on just writing controls to make your robot move around based on sensor input. And that also includes more high-level stuff like PID controls, PID loops, PID subsystems. Again, we implement all of the PID control loops ourselves so that you don't have to worry about having to do that and getting the math right. We also provide support for the official kit of parts components, so anything that you get in the kit of parts will just work with our libraries. That also goes for C++, Java, and LabVIEW. So WPI itself writes the C++ and Java components of WPILib. The LabVIEW stuff is written by National Instruments, and their stuff is mostly completely on its own. It's not really based on what we write.
Closed source.
And it is closed source, yes, like Jonathan just brought up. So to make it easy for everybody, it's open source, and we try to make it well documented so anyone can just go into the code and see what's going on and easily be able to contribute or help out with it.
One of the goals is that one of the things that you hear said a lot is the goal is to raise the floor, not lower the ceiling. So we want to bring everybody up and make it so that it's possible for everybody to do that do really powerful things as opposed to just reducing the challenge. Yeah.
All right, next slide. Cool. Who owns all the pieces? Kevin.
So I figured I'd take this one because this is basically what First pays me to do, is keep track of who owns all the pieces and make sure they're actually working on them. So starting on the left side here, that's what these folks at WPI, as well as Brad Miller and some other students, and now we've brought some volunteers into the WPILib development team as well. These are the things that they're responsible for. So the biggest piece is that top one, the WPILib, the C++ and Java libraries that you're all writing your robot code against that do things like they were talking about, interaction with speed controllers, PID classes, all that kind of stuff. But there's a lot of the other pieces that add into that as well. So you've got network tables in C++ and Java, so the NT Core library that was rewritten last year by one of the volunteers is in there. You've got the C++ and Java camera server and CS Core, which was new for this year, that is a part of the WPI team as well, even though that's done by a volunteer. A lot of the Java desktop tools that go with a lot of the WPILib software. So the Smart Dashboard and the Outline Viewer for some of the network tables and dashboard stuff. Robot Builder for working with the command-based robot and generating a lot of that boilerplate code for you. The Java installer to get the JVM over onto the RoboRio each time you image. Grip, as Jonathan mentioned, to do some vision processing stuff that there's another talk on Friday about. And the C++ tool chains for building C++ programs, cross-compiling, targeted at the RoboRio. This middle column is what our partners at National Instruments own. So the low-level RoboRio libraries, things that provide the low-level support for things like SPI, I2C. The LabVIEW libraries, as they mentioned, are done primarily in LabVIEW for LabVIEW teams to provide similar functionality to what you're getting out of WPILib. They generally call theirs WPILib as well, even though it's not developed by WPI, to sort of show that similarity of functionality. The FRC driver station is a LabVIEW program developed by one of the LabVIEW developers at National Instruments, as well as the LabVIEW dashboard that comes as part of that driver station installer. The FPGA code that does quadrature decoding, analog accumulators, all that kind of super low-level hardware stuff we do in the FPGA, and that's worked on by folks at National Instruments. And then the NI Vision Assistant, RoboRio imaging tool, that's all done by National Instruments folks. And then over on the first side, the field management system, so the FMS software that runs on the scoring server, as well as the field network configuration, the field access point, what's in the scoring switches on each end of the field. Those two pieces are done by other members of the first staff, and then I work on the access point. The driver station, robot, and FMS protocols, the way that all those devices talk to each other from a software perspective. We're the keeper of the keys on the final document for that. So we get a lot of input from the folks that are writing the driver station and things like that on what they want to see there, or these folks that are working on WPILib on here's some information that would be really helpful to have on the robot. But ultimately, first is the keeper of the keys on the protocols there and approving any changes that we do make. The robot radio is primarily my job to work on the firmware for the open mesh radios, and if we have to move away from them, to be identifying and developing new solutions. And then the robot rules is another one of my big jobs, as well as some of the folks on the Github Parts team, Jonathan Bryant and a few other folks, with input from the larger game design team, but primarily myself and Jonathan work on a lot of the robot rules.
Not me.
Not this Jonathan, a different Jonathan that works at First on the Github Parts team.
Are you taking questions during, or are you waiting until the end?
We'll probably wait to the end if that's okay.
All right, thanks, Kevin. All right, so this is just all the projects that we have as part of WPILib Suite. So that's all the stuff that we develop in-house to help out with, programming with WPILib on FRC robots. So there's the WPILib C++ library. This is one of the lower level things because the Java library also hooks into this in some cases. There's, WPILib Java library. So if you program the robot in Java, that's what you're using. There's a WPILib HAL, so HAL stands for Hardware Abstraction Layer. So that basically makes it so that instead of the library having to know about the hardware, there's this layer in between that provides some extraction, so it doesn't have to know how to interact with all this hardware. And this is really useful for doing simulation things, because in a simulator you don't have actual hardware. There's a Smart Dashboard, that's a Java-based desktop tool It lets you really easily look at sensors and motors and commands and subsystems and a whole bunch of other things on your robot during a match. It also lets you go into something called the live window, which if you put your robot into test mode, you'll be able to control all the components on the robot manually. It won't be running your robot program, so it makes it a lot easier. You know, if you move a slider to change a motor value, you can actually see if the motor moves on the robot. So if you're trying to troubleshoot something to see if a motor is broken, go into live window and move the motor and see if it works. There's the outline viewer. This is again this is a really small Java desktop app, and this is really, really, really useful for looking at the data in network tables. This is one of the most underappreciated tools that we have. It's really small, it's really light, it comes bundled with the Eclipse plugins. All of the desktop apps come bundled with the Eclipse plugins. So if you install Eclipse, install the plugins, you'll have all of this stuff right on your computer. So Outline Viewer just lets you see everything in network tables at any time. It lets you add stuff into tables, it lets you delete stuff from network tables. It makes it really easy to debug stuff that's going on in your robot without having to fire up Smart Dashboard and worry about layouts. There's Robot Builder. Kevin talked about this a little bit. This helps you build a boilerplate project for your robot using the command-based framework so that you don't have to write everything from scratch yourself. It'll generate all the skeleton code for you, and all you have to do is fill in the logic. There's Java installer. Again, as Kevin said, it's a small tool. It installs Java on the RoboRio after you reflash it because Oracle doesn't let us bundle it with the RoboRio image. Eclipse plugins, like I touched on before, so the Eclipse plugins bundle all the desktop tools, and they also bundle all the libraries, and they bundle a ton of sample programs. So if you want to look at how to use a mechanism drive or gyros or any kind of sensor or motor controller or command-based robot, from very simple examples to full-blown robot programs that you can just download onto your robot, and it should work if it's exactly the same as ours is. NT-Core, so this is a very low-level C++ library. It has builds for basically every major platform, RoboRio, Windows, Linux, OS X. So there was an original version of network tables that came out in 2012, which is written in pure C++ and another version in pure Java. NT-Core basically just does everything in C++, and it comes with wrappers for Java. Again, those wrappers just call straight into the C++ functions, so the Java stuff will run on every platform the C++ library does. There's CS Core, which is very similar to NT-Core. It's built by the same guy. It's a camera server core library, which lets you really easily interact with USB cameras, IP cameras, basically any kind of camera you can plug into a computer, you will be able to use with this, basically. There are some, so this is new this year, so there's some, it's not perfect, doesn't have everything in it so far. USB cameras only work on Linux, which is fine for you guys for FRC because, the RoboRio is running Linux, so that's not an issue. If you try to run CS Core on Windows or OS X, bear in mind that USB cameras aren't necessarily going to work. There's Frc Sim, which it basically runs a simulator of your robot and your robot program. So you can load in a 3D model of your robot. You can export that from SolidWorks, and then it'll simulate the robot program and make your robot model move based on sensor inputs and motor values that you're giving it. It's it's a little bit flaky, but it works. If you put in the time to do the CAD and get the models right and do the simulation stuff right, you'll be able to simulate your robot without having any parts manufactured yet, which is really good if you want to start programming by week 3 instead of waiting for week 5 or 6 like a lot of teams do. There's also Grip, which is written in Java. Jonathan and I are going to talk a lot about this on Friday at the Vision Talk if you want to go to that. Basically, it's another Java desktop app. It doesn't come bundled with the Eclipse plugins because it was built as a senior capstone project by Jonathan and one other student at WPI. It's also just totally standalone. It doesn't hook into any proprietary WPILib stuff. It lets you really easily grab image streams coming from an IP camera or a webcam or a USB camera or images that you have saved on your desktop, anything like that, any kind of image basically you can plug into it and start doing vision processing on. So you don't have to know any OpenCV, you don't have to know any C++ or Java, you don't have to know how to program, and you can write computer vision programs with this, which is really, really great. You're also able to publish basically any kind of information you can extract from images. You can publish that to network tables or HTTP or ROS if you're running this in an academic setting, which most of you guys probably won't be, but anybody at colleges or in industry, you're able to do that as well. All right, next slide. Okay, so this is just the dependency tree of WPILib. So this is how all of our components are based on more higher level stuff. So down in the left-hand corner, there's the NI RoboRio libraries. This is all the lowest level stuff that NI writes that lets us interact with the RoboRio and hardware on it, like FPGA and PWM stuff and digital inputs, outputs. All those I/O stuff is from the NI RoboRio libraries. Directly on top of that is the WPILib HAL layer. So again, that's the hardware abstraction layer. Instead of having WPILib call directly into these native NI RoboRio libraries, there's an intermediate step that, again, lets us do simulation stuff. And then, further up that, there's OpenCV, this is new this year, OpenCV. Previous years, there was NI Vision, which was NI's proprietary vision library stuff. OpenCV is much more popular. It's used, everywhere in colleges and research and in industry. So if you get to know OpenCV, you'll be able to use that basically straight away in college. So building on top of OpenCV is CS Core. CS, again, it's the camera streaming and camera using stuff. CS Core can hook directly into OpenCV, so you can get an image from OpenCV. It's stored as a matrix, basically, matrix of ones and zeros. And then you can give that to CS Core as a source, and then you can also get an OpenCV matrix out of CS Core so that you can directly do image processing on it. So you can have CS Core hook into a USB camera on your RoboRio, and then supply an image into an OpenCV matrix, so it'll just copy the data into it when it gets new data from the webcam. And then you can immediately do vision processing algorithms on that matrix. So you don't have to do any networking stuff. It's all right in that one program. There's also WPILib util, which is basically really small, really high-performant classes, mainly used by NT Core and CS Core and a little bit in the HAL. So this just lets us focus on high performance, basically. So you guys don't have to worry about slow libraries. So yeah, NT Core, again, on top of WPILib util. And then WPILib C++ and WPILib Java are both built on that entire stack. So at the very top level, which is what you guys are using to program your robots, are the actual WPILib C++ and Java libraries. And then way over on the side, that's all the tools that we have. So Smart Dashboard, that hooks into network tables internally so that I can see everything that you're pushing to the Smart Dashboard. So in your robot program, if you ever do smart dashboard.putData something, then that's how it appears. It puts it in network tables, and then the Smart Dashboard tool on your desktop will see that change and then display a widget for that data that you put in. Again, Outline Viewer, same thing, hooks into NT Core just to show everything in network tables. There's Grip, which is built on OpenCV. It's not using the OpenCV that we're using for WPILib. WPILib is using all of the official OpenCV libraries. So Java, C++, Python. We don't do Python, but WPILib Python does. So for Grip, we use a different library, one that's written for Java developers, because Grip is written in Java. It offers a lot more functionality than the official library does. But internally, it works pretty much exactly the same. So if you know OpenCV, you should be able to, tinker around with the internals of Grip, write your own operations that call straight into OpenCV, and it'll look pretty much exactly the same as official OpenCV stuff would. Grip also depends on NT Core because there are publishing steps, so you can publish stuff to network tables that you can hook into from your robot. There's also sources, so you can grab something from network tables in Grip. So some Boolean or number or something that you want to use internally in Grip, you can grab that from network tables. All right, I'll try not to bore you too much. So what's new in 2017? A lot of you guys are probably looking forward to this one. So there's a new camera server stuff. That's CS Core. So it has built-in OpenCV functionality. Like I said before, you can extract data straight from OpenCV images and then put data from a webcam or IP camera or whatever straight into an OpenCV image so that you can immediately do image processing on it with OpenCV functions. There's also new Smart Dashboard widgets that reflect these changes because the camera server image stream format actually got changed this past year. So we had to update Smart Dashboard to reflect that change. There's also a big rewrite for the hardware abstraction layer. This is mostly internal stuff. It doesn't really affect the libraries a whole lot. But this was really done to make simulation a lot easier. So that's going to be worked on a lot over this summer and off season. So hopefully you'll be able to have really good simulation support this coming year. There's also a lot of optimizations done internally just to make the library generally faster. Again, this doesn't really affect you guys a whole lot. It didn't change any of the public-facing APIs, but it's just something to be aware of. It's better this year than it was last year. New network table stuff. So originally network tables update rate was limited to 100 milliseconds or 10 hertz, which was kind of slow. It introduces a lot of latency, especially if you're trying to communicate from your robot to your driver station, because you have the network table delay of 100 milliseconds plus whatever the network delay is, plus the network table delay again coming back. So now we let you lower it all the way down to 10 milliseconds or 100 hertz update rate, which really lets you get that data not exactly real time, but still a lot faster than you were able to before. We also added an Xbox controller class this year, so you can just plug in an Xbox controller and use it. In past years, you had to do something kind of sketchy, write your own or find someone else's that may or may not work. Now there's official support for it, so you can just use an Xbox controller. A big change this year was vendor libraries. So instead of having everything that vendors supply baked into WPILib, so CanTalon, stuff like that, built by CTRE or Wpi Labs, they have their own libraries that they build, and they offer those as basically standalone downloads from their websites that you can download and install and build against. But we don't bundle that anymore. And we also moved development to GitHub. So now it's totally open source. Anybody can see it. It's up on GitHub. Anybody with a GitHub account can open an issue if you find a bug, or open a pull request if you want to add a feature. We're going to talk about in a little more detail later on about what kinds of stuff you should and should not be doing on GitHub with our repositories. All right, so that was the overview. Now we're going to talk about how we actually build WPILib. Jonathan?
Hello. Hi. So, Gradle. In the old world, we used to use Maven and CMake, and a combination of the two together, and it was slow. I worked at this point when this was going on, and it was a very slow development process. So Gradle is a much faster build tool. It has a lot of really powerful aspects to it, including support for not rebuilding and not redoing things that you've already done. The way we use it, it's open source. It's used in industry and in a lot of open source projects to compile Java code and C++ code to create artifacts that can be shipped to users. In this case, you guys. It has a plugin-based architecture, so it doesn't come with everything built into it. You have to basically pull things. People have written plugins for additional compilers, doing different things, adding support for Python and things like that. And if you can pull those in, and it has really, really great multi-project support. So if you have, as we do, a lot of different small little projects that all produce different outputs and need to get combined together in different ways in different projects, Gradle is a really powerful tool for dealing with these kinds of dependency these projects with these sort of dependencies. And it has integrations for all the popular IDEs, IntelliJ, Eclipse, NetBeans. And most projects in our world and in any world you see the project is using Gradle, you can just clone the project, and as long as you have Java installed, you can do a Gradle W build, because Gradle is shipped within the repository, so you don't even need to download Gradle. It just comes built into the code base that you've downloaded. And desktop projects like grep you can run with Gradle W run on the command line. In grep's case, it's actually :UI:run. Yes. So build outputs, yes, can be shared. Yes, build outputs can be shared between yes. Okay. Yeah. So build Gradle outputs. dependencies that are basically Maven dependencies. So Maven has this whole architecture around dependencies and artifacts and how they should be structured. And so Gradle basically took this ecosystem that Maven had and said, this is really great, and we're just going to keep using it. So when you hear the word Maven-style artifact or dependency, it's because Gradle just said that world already exists, and we're just going to plug into it and create artifacts like Maven. So we work just like we're producing Maven artifacts, but they didn't reinvent the wheel, which is really great. We have 2 repositories where you can get releases. We have the official release repository, which is at that URL up there, and then we have nightly development builds that get released whenever Jenkins rolls. That is at that other address. You can publish you can clone any of these projects and publish a release locally that you've made the change. If you make changes to WPILib and you want to use what you've changed and try out what you've changed in your code, you can run a publish, and it will publish it to that directory on your machine, and then you can try out the output jar or output projects, Eclipse plugins if you'd like. All of the dependencies that we have are suffixed, and the suffix is helpful because it lets us break up. It helps us produce different artifacts for different platforms, so you don't end up having to take on Windows dependencies if you're running on OS X. You don't need to have the extra overhead of additional C++ libraries, sorry, C++ native bindings. And we have 2 different versioning schemas, and why that is because for some things like WPILib, we have a versioning schema that's very specific to first because it makes a lot of sense. So the versioning schema for first, like WPILib and those sort of tools, is the current year, and then the required update. As in the required update version, you need to be running this version in order to be legal to run on a first field. And then the last number is the optional update. You can run any of the optional update versions. You don't need to have the highest of that in order to be legal to run on a field.
Just in case anybody's not on 2017 3.1, we did this wrong this year. You don't need, there's nothing in the rules about what update. If you're on the kickoff release, you can go play matches. But that's the intent of what we're supposed to be doing.
Yes.
We just didn't label them right this year.
Yes. So, moving forward in next year's goal, and then for other things, especially like grip, we're trying to follow semantic versioning. And if you look up semver you Google semver, you'll see what semantic versioning is. Basically, major version is we will not break any. If anything is a breaking change, you bump the major version, and if it's not going to break anything else, it's not going to break any code, it's not going to cause any weird side effects, you can just make a minor version bump or a patch version bump. Creating vendor libraries. Off to Sam. Also keep track of the time. We have to have time for.
All right, so it's 7:30 right now, so we have about 20 minutes left. And my phone thinks I'm talking to it. That's no good. All right, so again, new this year, vendor libraries. So we split out all the proprietary can talent stuff, removed all of it from WPILib, and having vendors like CTRE develop those themselves and develop their own plugins to WPILib, so that we don't have to distribute it. There's some legal stuff going on with that. So the WPILib Eclipse plugins support direct integration with the vendor libraries. So the vendor libraries get put into a specific folder on your file system on your computer, and the Eclipse plugins will see that. They'll see those jars or zip files or however they're bundled, and then extract them and then allow you to use them from your user program. You don't have to do anything funky with adding dependencies or anything with this, which is pretty nice. So all you have to do is download the jar, stick it in this folder, you're done. CHRE also has their own installer and extractor tool for Windows, so you can just download that tool and run it, and then it'll handle everything for you. So yeah, again, Can Talent Stuff by CTRE, Navex by Wpi Labs. They're using the vendor-based approach, so they're writing their own libraries, hooking into WPILib, instead of, again, having it be part of WPILib and having us have to distribute that. There is a template on GitHub, so if anybody wants to write their own plugin, so if you have like a sensor that you're developing or a motor controller that you're developing and you really want first teams to be able to use it, you can use this vendor template to basically make your own plugin to the WPILib library. And that's it. You just use the template, you build it, and distribute it however you want. So on your website, on Chief Delphi, however. Also, something to note about vendor libraries is that they have to have C++ and Java support, because we want both versions of both languages, C++ and Java, to be basically identical in every way. So anybody who is used to working in Java can very easily switch to working in C++ or vice versa. There are some language quirks that we can't get around, but besides that, we want to make everything as identical as possible. Okay, so WPILib, the actual libraries you guys are using. All right. So there, again, there's a Java and C++ libraries. Each one of those has their own set of classes and functions and methods that basically let you write your robot program without having to worry about hardware implementation stuff. They contain all the libraries you probably already know: encoder, Talon, motor controller, speed controller, sensor, analog input, robot base, robot drive, and a whole bunch of other stuff that we include to make life a lot easier for you guys. There's the HAL interface directly between these libraries and the NI libraries that are running directly on the RoboRio. You guys don't have to worry about this unless maybe you're making your own vendor-based plugin that has to have some hardware capabilities to it. The dependencies for the libraries, basically everything that we have: NT-Core, WPI Util, CS Core, the NI libraries for the RoboRio, OpenCV, and the FRC ARM tool change that we have to let you be able to compile your C++ programs on your development laptop or desktop or whatever, instead of having to compile all your code on the RoboRio, which would be very, very slow. So future plans for WPILib. We're planning on adding in a holistic data logging framework. So if any value changes anywhere on anything, sensors, motors, anything, it'll be logged and you can be able to do playback with that. We don't know how you'll be able to do that. It could be through our own custom tool. It could be through the NI logging dashboard using that already existing stuff. But regardless, next year you should be able to have logs of basically everything that happens on your robot. So you'll be able to tell, if your battery voltage, goes down and your RoboRio browns out, or if your motor, stalls, you'll be able to see the current draw for that motor. Everything like that you should be able to see and have logged, and it should be available on your RoboRio or possibly on your driver station. A different solution for the net console, again, kind of hooks into this. A lot of simulation improvements that we have planned to simulate everything at the HAL level so that we don't have to duplicate code between the simulation libraries and the actual WPI libraries. So everything is just done from the HAL, so the HAL will abstract away the simulation stuff versus the RoboRio stuff versus anything else you feel like running it on. So if you want to run it on some custom test hardware, you could be able to do that as well. We're also planning on adding model-based feedback control. So it's it's pretty mathy here. But if you have a model of something on your robot, like a mathematical model of how it will react, basically, you should be able to control it, with much better control, basically. Instead of having to, tune your PID loops or stuff like that, you should be able to just make a mathematical model and have it work. Also, motion profiling, path planning. Path planning, this is something that a lot of high-level teams seem to have done recently, like 254, and a whole bunch of other teams have done path planning to make it really easy to drive your robot from point A to point B. So if your robot starts somewhere on the field, you can be able to drive, say, to a hopper, get all the fuel balls to dump in, and then drive up to the boiler and shoot everything. So we're planning on having path planning put in so that you can just give it waypoints and possibly some control points to control the curves between the points, and then just have the robot drive that. So that'd be pretty cool to happen next year. There's also plans for having a low-cost hardware test environment so that if you want to set up some test platform to run your FRC program. So instead of having to have a robot built to test all your code, you can have this really cheap hardware thing that you can just run your code on and make sure it works before you have a working robot. Next slide. So desktop tools. This is pretty cool. I say this because I've worked on all of these. So the Smart Dashboard. This was originally written, I think, in 2010 or 2011. So that's 7 or 8 years old at this point. It basically provides a Java GUI straight into network tables. And that's basically all it is. All of the cool widgets that you see, that's all hooking into the network table stuff in the Smart Dashboard table. And any changes to network tables from your robot will almost immediately show up in Smart Dashboard, plus network latency and network table latency. You can just display stuff as simple text fields, so like current draw or battery voltage 12, for example. You can also have really complicated widgets like this compass here for showing a gyro or an actual compass. There's also a graph for like motor speed, so if you want to see your motor speed over time, you can see that really easily as a graph. Yeah, so there's also options for adding commands to Smart Dashboard. So if you want to run a command straight from the dashboard, you just hit a button and it'll run, which I think is pretty neat. It lets you set variables on your robot, like with the sendable chooser. I hear a lot of teams have been having issues with that this year. We're working on it. It'll be fixed. The idea behind that is that you can define some autonomous commands that you can run. So if you want to, say for this year, you want to drive straight in for the center peg or one of the left peg or right peg or left hopper or right hopper, something like that, you would have the sendable chooser object on your robot program that gets sent to the Smart Dashboard. And the dashboard will show that basically as a bunch of radio buttons, and you can select one of those buttons to choose which auto mode you're going to run. And then it'll just run it, theoretically. Outline viewer. Again, I said this before, I'm going to say it again. This is one of the most underappreciated tools that we have. If you want to see what's going on in your robot, open up Outline Viewer. I cannot stress that enough. I also wrote this, FYI. It lets you see everything that's going on in network tables in real time. It lets you add values, remove values, edit values really easily. So this is just a static image. If you bring it up, launch it from Eclipse plugins, you'll see, just this root folder. Basically, you can right-click on it, add some key. So right here, this is showing some data that grep is spitting out. So if you want to mock this up, you right-click on root, hit add number, /grep, /myContourReport, /centerx, and then you give it whatever value you want, and it'll show up. And then if you have anything else hooked into that, like Smart Dashboard or grep or your robot program, it'll respond to that because network tables, any change in network tables gets sent out to everything on the network that's also running network tables. Robot Builder. I've also worked a lot on this. It makes it really, really easy to make the skeleton and the framework for your robot program. So you don't have to worry about how you set up your program. This does all of it for you. All you have to worry about is running the logic. So, well, there's nothing really in this example here, but you can imagine having a whole bunch of subsystems like a drive base, an arm, an elevator, a claw, shooters, climbers, all that stuff. And then you have commands for each one of those. And then you set those all up in Robot Builder, you generate code, and then it'll generate all the classes for your subsystems, for your commands, for your robot map to map what sensors are in what ports, what motor controllers are in what ports, CAN IDs, all of that. It sets it up for you. And then all you have to do is basically write the logic for each command. So you have like a climb up command for your climber. You write the logic that sets the climber motor value. And then you have a climb down command that you make the logic to set the motor that makes it climb down, stuff like that. It's really easy. You don't have to worry about doing any of the skeleton stuff yourself. Grip. Jonathan, you want to take this?
Yes. Hi. So, as I said before, I wrote grip as my senior project at WPI. I'm not an alumni. So grip allows you to develop computer vision algorithms without writing any code. It's a completely graphically represented image. GRIP stands for Graphically Represented Image Processing Engine, and it lets you create computer vision pipelines using a drag and drop GUI with and create little simple connections. It is in itself a strongly typed language that lets you create these pipelines, and then you can publish values to network tables or to a ROS node or to network. Yeah, HTTP. Thank you. And we also have cogeneration support that is added this year. For you can basically take your pipeline that you've created and go to tools, generate code, and you can generate Java, C++, or Python code, and then that the code that generates ties in really nicely with CS core, and you can just dump that code into your robot program and have it work. You need to. It doesn't support things like network tables operations, but for the rest of the rest of the computation, it works really, really well.
If you want to see us go more in depth into grip, we're giving a talk on Friday afternoon at 1:30.
Yes.
It's a 2-hour presentation. It's a lot longer than this. We'll be going very in depth into all the vision processing stuff that you can do in WPILib and with grip. So if you're interested in that, go to that talk. It's 1:30 on Friday.
Yes. We have about 10 minutes left, so I'm going to try to, right? 10 minutes? Is that? Yeah, we got to kind of zip through these. Yeah, so can we bump past this one?
Well, we don't have much after this.
What questions?
All right. So future plans for the desktop tools. We're planning on doing a complete rewrite of Smart Dashboard and SFX. If you were really paying attention, you would have noticed that we didn't list SFX anywhere up here. It's because it was written with Ruby, JRuby, Java, JavaFX, and JRubyFX, plus all the build tools to support all of those languages. So nobody wanted to support it. So it just kind of stagnated after the original author wrote it and moved on to something else. So it had a really nice idea, written in JavaFX. Anybody can just make a custom plugin for it. But unfortunately, no one was able to maintain it, so it just kind of stagnated. So over the summer, we're planning on doing a complete rewrite of both of these. That will also hook into like the cool logging framework that we talked about before. For outline viewer, small change, you should be able to just type in your team number, and it'll hook up into your robot generally, instead of having to put in the whole IP address.
There's a pull request for that I actually think just got merged.
Cool. So for grip, dark theme, okay.
Something Sam's working on.
Yeah, well, there's a PR open for that. Basically, we're planning on making the user experience a whole lot better. So, if you really like dark themes, like with Chrome or IntelliJ or Eclipse or something, you can have a dark theme if you want. We're also planning on adding playback for video files. So you can, for example, on the field, you can have your robot basically record everything that it sees as a video file and then play that back through grip later on if you want to see, if something went wrong. Or if you want to, on kickoff day, you can walk around a field with a camera to just record basically what your robot would see, and then you can play back through that video file later on instead of having to save, thousands of images to go through. Something that's been in the works for a while is custom Python operations. So if you want to, if there's something that grip doesn't let you do, you should be able to write, a small Python script that hooks into it that lets you do whatever you want to do. We're also planning on doing automatic file backup. So like Robot Builder, it'll remember what you had open before. You don't have to go manually open it. And also GPU acceleration, which is pretty big. Right now, grip only runs on the CPU, which can be pretty slow. Running on the GPU can make certain operations up to 30 or 40 times faster. So cross-platform core libraries. I think we can skip over this stuff right now. Does anybody here really interested in the low-level stuff? Yeah, you can take a picture.
We'll also be here afterwards if you guys want pictures of any of the slides we've got too. Good. Awesome.
Cool.
You want to jump to the
All right, low-level stuff.
You want to jump to the GitHub one just to get that?
Sure. Yeah, so camera server library stuff. We're going to be talking about this, again, like grip, a whole lot in depth on Friday afternoon.
Yeah.
So if you really want to know about vision stuff, go to that talk. So future development stuff. Again, this is all for the low-level library stuff. So do you want pictures of this? Got it. Cool. Clips. Yeah, it's on
Yes.
Google Drive. So if you're interested, we can give you a share link for it.
Yes, absolutely.
We are planning on finding somewhere to put it on the screen steps, either a link or a.
Yeah. Yeah. We could also save it as a PowerPoint. Yeah. We could save it as a PowerPoint and put it up.
Houston as well. I just haven't had a chance to look where yet.
Yeah. All right. Close plugins,
Contributing.
Yeah.
Okay, how you guys can help us out. So we are now part of the beginning of this development cycle was we moved to GitHub. So it was on Team 4 or something else before, and it was hard to get to. And people basically we wanted to open this whole tool chain up so anybody here or anybody in the world can contribute to this. So we're now on GitHub. You can find all of the projects at github.com/WPI suite, and then all WPILib is where the WPILib libraries live. We work off of a basically, if you want to contribute, you can go to GitHub and you can fork the project, top right corner, and that will create your own clone of it in your GitHub account, and then you can clone that. And using the GitHub workflow, you can create a pull request to merge code back in. So you don't need to be a contributor. You can just you don't need to special access. You don't need special permission. All you need to do is fork it, and then you can open a pull request back against our project without any interaction with us. If you have intentions to add features, please open an issue first and discuss it with us, so you don't spend all this time working on anything on code and having us say we can't maintain this. So our GitHub workflow, we use Jenkins, Travis CI, and AppVeyor. Jenkins is our own proprietary, or not proprietary, but internal build tool that runs on WPI software. It actually runs motors in somebody's office at WPI when you push code. Travis and AppVeyor run automatically. What? No. We're running it on our own servers though. Like we have our own machine. Oh no. Yeah, please. Yeah. So Travis and AppVeyor, Travis CI and AppVeyor, they're both free services for open source tools, and you can run any code on them that you have open source projects for. So any GitHub project. So we use those, and those run on somebody else's hardware. So those run automatically. Jenkins runs on our hardware. So we don't want somebody's randomly writing code that's malicious. So we don't. If you make a pull request, we don't run it automatically. It won't automatically run on our servers because we don't want you doing something malicious to our network. So we have to explicitly approve the pull request before it'll get deployed and run on the Jenkins machine. And it runs unit and integration tests, and then after a merge, Jenkins checks out and builds the changes and builds all the downstream dependencies. So it makes sure that everything works. Any change that happens at the high level works with everything down the entire stream. Yeah. Next one.
Just a quick question before I lose it. The Jenkins jobs and all of that, you guys publish that as well, so we can go on Jenkins server?
No. That's private. We have our own private. I mean, most of the things you can run the jobs with Gradle, but I mean, some of the workflows are very specific to our hardware, especially around running Mac and Linux and things like that, and all those different platforms we have to build artifacts on. Yes. So one of the really important things about WPILib and all these tools is they have to work for every single team. It's really important. So and we need to be able to support submitted changes. So if you write code or anybody writes code that is hard to follow and can't be maintained, that doesn't work for us because we have to make sure that it works for all the teams. It also, teams need to be useful, or additions need to be useful for a wide variety of teams, not just something specific. So contrived example, we don't need people's autonomous code because it's only useful for you or your team. We need it for we need to be something that's useful for everybody. And changes in one language, especially features, need to be added in both languages because, this drives me nuts as a developer, but you have to add it to both languages. The Java and C++ libraries are very, very closely written the same. A lot of the Java code was actually the C++ code, then copied into a Java file with all the compiler errors fixed. So they're very closely related. So if there's a bug in C++ or in Java, they're probably in both languages. So, but for bug fixes, you don't need to fix it in both languages. we welcome bug fixes. Please open bug fixes. If you find a bug, please open it. We will port it to the other language. If you're doing a feature, you need to make sure that it goes to both languages. Yes, that. I think this covers pretty much what I was just saying.
So what you should not contribute.
Yes, and that's also what I just said.
Cover this.
What you should not contribute, if you are not sure, open an issue first, and we will get to you, and we will say, yes, that seems relevant. No, that does not. We'll have a discussion with you. We won't just shoot it down, but we will have a discussion with you. So please open an issue first if you're not sure. If it's something really simple, documentation is really, really helpful. So if you are going through the code and you're like, I don't understand what this means, and then you finally understand what it means, and you want to contribute that back, that's really, really useful. Major rewrites, that again really needs to be discussed.
If you don't know which little repo, like you have an issue, either a bug fix or a feature request, and you don't know where it belongs, put it in all WPILib. That one has the most of us subscribed to it. And we have tools that let us move. If it's supposed to be somewhere else, we have some tools that let us move, and we'll notify you that we moved your issue to another repository if it belongs in, say, NT Core, because it's a low-level network tables thing, not a high-level thing in the C++ or Java libraries. So take a look, see if you can figure out where something goes. But if you're stuck, we'd rather you tell us in the wrong place than not tell us at all. So throw it in all WPILib, and we'll get you sorted out.
Chief Delphi is not a place to post bug reports. We do not look there. We sometimes look there, but not regularly. So if you have an issue with our libraries, please open them on GitHub. We will find those. Yes.
Don't think we need to talk about this.
Yeah. Questions? Okay, we finally reached this point of our journey.
Only 1 minute late.
Yes, right. 1 minute late. Okay, we have questions. You had one originally.
I'd rather see some students.
Yeah.
Students have questions first.
Yes.
What do you plan to be different for your motion profiling in the WPI labs versus some of the motion profiling that already exists in like Cantalon library?
So neither of us have really looked at that too much. We're mostly focused on tools. Unfortunately, we're the only ones here at the moment. Kevin says he can do something.
So in terms of the specifics, I don't know what the implementer is planning on. Certainly it would be an implementation that would allow you to do it with any speed controller, not just Cantalons. But all the things that were on there for future plans, like we skipped pretty quick through the development schedule, but about championship is the time that like we have a lot of ideas on the page. So I certainly wouldn't guarantee that everything you saw up there is things we're going to implement or is really concrete thoughts. The championship is the time that a lot of developers end up in the same building together and get to have a lot of off-the-cuff conversations about this kind of stuff. So more concrete thoughts, plans, and ideas and prioritization of things will be coming in the next couple weeks. And the particular individual that's really excited about working that is, not here to comment on what's in their head right now. And I don't know exactly what the differences will be implementation-wise, but it would certainly be flexible across everything that implements the speed controller class.
Yes.
Is there plans for an official plugin support for IDEs outside of Windows?
At the moment, no.
Yes. We would. The ongoing discussion that has gone on is we'd love to support IntelliJ, but there's no C++ support. So that's kind of the official word on that. But not that there's any plan there, but like that's one of the things that Brad has talked about is that IntelliJ would be great, but it doesn't exist. So, yeah.
Anyone else? Sure.
What were some other libraries that were dropped in addition to the Cantalon libraries?
Cantalon and Navex. As
Cantalon and CanJaguar are the two that were in WPILib and got pulled out. All of the other third-party ones that exist now were never in WPILib. So the Navex stuff was never integrated. The Mind Sensor stuff is new this season. There are some others. There's one for ScanSense LiDAR, I think, that Peter Johnson wrote. But none of that stuff was ever in WPILib. It was just CanJaguar and Cantalon that were in and came out.
There's another question over here. Yep.
Speaking of vendor libraries, is there a way that we can kind of get like a central repository of these vendor libraries?
There's a page on Screen Steps that has links to all the ones I know about, except for that ScanSense one. And Peter put a comment on there for me last week at the talk in Houston, and I haven't added it yet. But there's a comments box on the bottom of every Screen Steps page. If you guys write something that you have instructions or an installer to put things in with the vendor library system, fill out that comment box on the bottom of the page and we'll put it up there. We want to let teams know about it.
I guess more of like, could we get like an Eclipse plugin repository or something? Because one of the issues we have with our team is making sure, does everybody have the latest Cantown version and install it the right way? And does everybody have the Navex library and that type of stuff?
So putting it all in an Eclipse repo puts us right back in the situation that we were trying to get out of by unbundling it, which is it makes us responsible for maintaining a complex piece of software that's done by a third party, and it in some ways may link updates and things like that.
I guess could it be possible to have that in our code repository instead of a local user?
So it could be possible to have it set up as like a Maven repository. So have it uploaded to some Maven server somewhere that you can download as Maven artifacts. That's just a possibility. That might not ever happen, but
We can also look into and document potentially folder configuration, like you're talking about if you want to be able to check that folder in with your code. That should be possible, depending on how flexible like their installers are with install location. I can take a look into that.
Yes.
Worked in the industry for 25 years. You're not going to get that when you get in the industry, but you're going to have to apply law, make sure everybody get used to it. It's the way it works.
Yeah.
There's licensing and distribution issues with trying to bundle various vendors together. They don't want that, especially when they're competing vendors. Like Talon and Jaguar, they're not going to want them together. So this is something that
So just to make sure, like that wasn't, CTRE was not the primary driver behind pulling that stuff out. It wasn't a Jaguar, Talon conflict thing. It was a growth of first, how do we maintain WPILib? Having their updates synced to ours created some issues for us, as well as having an increasing number of devices of that level of complexity as Mind Sensors were starting to work on their CAN motor controller, as the Kawai guys were putting more and more complexity into their software that never was in WPILib, but people were asking, why is this device in, why is that not? We really needed a more flexible, scalable way to let these vendors create really cool devices with complex software to let you guys do amazing things, but we couldn't keep putting it all under the same roof and have this same, Brad and a couple of students maintaining it. It just wasn't scalable as we continue to expand the number of really cool, complicated devices, and so we had to come up with a more flexible way, which makes the install and dependency management part a little harder, but gives everybody flexibility to do updates on their stuff and gives us flexibility to not have to keep track and do a lot of integration with an increasingly large number of vendors across an increasingly large number of devices.
Thanks. Yes.
yeah,
do
come
we-
talk to us after.
Yeah, USB drive or something? We can send it to you via email. Probably, yeah. Anybody else? Yes.
So with my team, we are trying to get vision to work using network tables along with smart dashboards.
Yep.
But there's an interference with the network tables, and so we couldn't use both at the same time. So what our team ended up doing was we made a personal smart dashboard without using network tables using Java and Linux.
So were you doing the vision processing stuff in Smart Dashboard?
No, we're using Jetson. There's no need to
It sounds like something maybe come talk to the guys down like tomorrow when they're in the WPI booth, or come talk to some
Yes.
of the CSAs about what you ran into, because those, as a premise, what you described should work. Like, you can have other network tables clients and Smart Dashboard all running harmoniously from a architectural standpoint.
Right.
There may have been implementation details that caused an issue.
So come talk to us. We'll be down in the pit area.
Robot Service Center behind
Thank
the
you.
admin.
Yes. You had another question?
Yeah, like another thought is that we use JavaFX, but JavaFX didn't seem to work with the robot.
JavaFX on the RoboRio is not supported by the JVM configuration.
Yes,
It's on
that.
the RoboRio.
Yeah, so the RoboRio is a headless device. It doesn't actually have a graphics chip in it, so it can't actually support any UI libraries at all.
Yep.
So there's a stripped-down headless version of the JRE that's running on the RoboRio.
It's also why you can't run grep on a Raspberry Pi because of reasons surrounding Oracle not supporting JavaFX on ARM chips. Yes. Anybody else? Yes.
Make a major contribution to WPI. Can you buy those WPI developer shirts?
No.
No, single print, sorry. Anybody else? Yes.
Smart dashboard getting rewritten. So one of the biggest issues we were running into with my team was that network. So we use Git a lot. Each student or collection of students were very much project branch based. So student was going to work on some particular project or branch where it's branch by branch. We have bullets of branches. It became a big problem when they would start testing the branches on the robot, where network cables would get very polluted with various, this had a different particular sensor of this or
Right.
that.
Yeah. So there is a function with network tables to delete everything off of network tables all at once.
Where is that?
Oh, it doesn't work with Open Outline Viewer. It doesn't delete it from down Outline Viewer.
Yeah. So I'm not entirely sure how that works. I haven't looked into it very deeply. It might only work if there's only one client, one network tables client on the network at a time. Because
Automatically have two because you have your PC and
yeah, so normally you should.
RoboRio's the
Yeah.
server. Your desktop is the client.
So specifically, it's Smart Dashboard or Outline Viewer are individual clients. It's not your desktop. So if you close Outline Viewer and Smart Dashboard on your laptop and shut down the RoboRio, that should be enough to clear out all the network tables caches, so that when you restart the RoboRio, it'll be completely fresh.
didn't always do that, and it's very painful. We can have a big hammer that just says, boom, delete everything and have the robo, and everybody just republish.
There is one. We just may need to document.
Yeah, so you can open an issue on GitHub for that.
Yes, please.
If there isn't one open already.
Yep.
Because that sounds like something that'd be really, really good to have.
Yes.
We were constantly shutting down the robot, everybody had, all the laptops, just
Yeah, that's fair. Yes.
Okay, so grep has a function to generate the OPCV code.
Yes.
Right? So if you want to run vision code on a coprocessor, you recommend generating the code and running that in headless.
Yes. That's the current workflow.
What do
we
you mean by running headless?
So like my team, we're using a Kangaroo as a coprocessor, so we're able to start grep and run that like in Windows. But would you recommend just generating the OpenCV code and running that?
The good thing about the Kangaroo is that you can plug it into a monitor and have grep running and just see what's going on. So I would just run grep as you would normally on the Kangaroo. Just unplug the monitor when you put it on the robot.
If you're having problems, yes. If you're not having problems and it's working fine for you, if it's not broke, don't fix it, right? So, yeah.
If you're trying to run it on like a Raspberry Pi or a Jetson or something like that, then yes, I would recommend generating code to run on that.
Yes.
Are there any other questions?
Yes.
We have more general like documentation helps for like the screen share or whatever it is.
Screen caps?
Or the maybe wireless protocol. Where would we put those type of requests to change here or there?
If you have screen step stuff, writing it out like as a Word doc or a Google doc or something like that, and then putting a link in the comment of either the most appropriate document, the closest document if it's a new thing, that's probably the easiest way to get it in there because we can't really give a lot of different people write access to that. But it should be pretty easy for me or somebody we have working on the documentation to port. If you look at the general format of like image, text sort of thing, the way the screen steps is laid out, if you write some documentation up like that in a Word doc and then post it somewhere, some file sharing, or as a Google doc or something and give us a link, I think we'd be happy to, review, edit, and post that kind of contribution as well.
For grip, I mean, we're a little bit of a special snowflake. We have wikis, the GitHub wikis, so anybody can go in and edit those if you find that there is lacking in documentation about setting things up and things like that. So you can't do that with this. There's grip screen steps lives documentation that you can't do that with, but if you're doing stuff with a wiki, you can. Anybody else? Yes.
Network tables on the Java side, it seems to use a lot of GNI.
Yes.
Yeah, that's because it's hooking directly into NT Core. So instead of having to write everything twice, copy it between C++ and Java, it's just entirely C++ with JNI bindings on top.
Trying to navigate that, I guess somewhat, I guess there's any documentation with regards to that because I wanted to get in there and fix something.
Yeah, not very much. Yeah, there's not very much documentation for the JNI stuff, unfortunately.
So you use JNI directly, you don't use like JCC?
Yeah, it's basically direct JNI bindings. So there's like a whole network tables JNI class in Java that just defines almost all the functions in it are just straight native calls through JNI. And then the network tables class, just hooks into that network tables JNI class. So yeah, if you want to contribute documentation or something, again, open an issue on GitHub. I've brought this issue up with Peter Johnson, who's the developer for NT Core. So it's on his radar, at least, to improve docs. Yep.
So to really see what's going in there, I have to pretty much have a C++ version of the network.
Yeah, you would have to go through the source code of NT Core.
There's probably some way, if you want to do a debugger, you can probably, I'm guessing there's a way to connect to it with GDB, but I'm not certain about, to debug the C++, once you dive into the C++ code, I'm not sure how you can do debugging in C++ code, but there's probably a way of doing that with GDB. Anybody else? Any other questions? Going once, going twice. Sold. Okay. Thank you all for coming. I hope that you came out of here learning a lot more. And if you have any questions, feel free to come up. If you didn't ask them, please feel free to come up and have a chat with us. We'll be here for a little bit. All right. You guys have a good rest of your week, and best of luck at Worlds.